next day or two. Okay, I'm actually done now. Daniel.
Yeah, no problem. This is a living presentation, so any good questions asked during, Viraj might bring them up, or we'll talk about it afterwards. I'm really excited to talk about this topic, and yeah, let's dive in. So what's new with Airflow and Kubernetes? So when we're talking about Airflow and Kubernetes, there are three main things that I want to discuss with you all. The first is, of course, the Kubernetes executor and what has changed in the Kubernetes executor in Airflow 2.0. The second is the Kubernetes pod operator, and we could even dive in a little bit on best practices as well as like what is new with that. And finally, and this I think is a topic that I don't know has been gone over too much, but it's probably one of the things I'm most excited about. We're going to talk about what's called the KEDA autoscaler, which is the Kubernetes event-driven autoscaler system, which we have made work for Airflow specifically for the CeleryExecutor. So let's start out by talking about the Kubernetes executor. And before we dive in, just a quick overview of what is the Kubernetes executor. And essentially, the Kubernetes executor, when we were creating it, the idea is that Airflow before the Kubernetes executor did not have a good autoscaling story. You had to allocate Celery workers, and you had to guess how many workers you needed. And then so you might end up with oversubscription, which is wasted space, or undersubscription, which causes you to miss your task SLAs. So with the Kubernetes executor, we kind of created a native auto-scaling system where every single Airflow task is launched as a unique pod. And so when you're not running any tasks, you don't have any workers. And we also wanted to expose elements of the Kubernetes API to empower the data engineer. We wanted to make sure that there's this conversation going on between the data engineer and the data platform engineer, such that if you are the person writing the DAG, you have access to these elements where you might have a task that requires extra CPU, or a task that requires extra memory, or you have a task that's just monitoring a Spark job and can be very lightweight. So we wanted to expose some of those features. Now, when it came to the old architecture of the Kubernetes executor, specifically in Airflow 1.10, we first kind of came in with this idea of simplicity. We were thinking, we don't want to have people figuring out the entire Kubernetes API. I'm sure that we can just kind of expose a piece of it in a flat fashion, and that way people won't have to think too deeply, and we can keep things simple. And we got a lot of feedback. We learned a lot from that experience. And probably the biggest thing we learned is that don't try to keep up with the Kubernetes API because it's so big and it's so constantly changing. And what was really interesting is we got a lot of PRs saying, hey, I need this specific feature of the KDS API to do this specific job. And that just kind of added more and more code. And we wanted to essentially rewrite the Kubernetes executor in a way that offered the full flexibility of the KDS API, reduced Airflow's code footprint, but still made it that the top level data engineer had to think as little about Kubernetes as possible. So you could have anywhere from full control in the DAG to having 99% of the code written out somewhere else, imported, and then just changing the individual features you need to change.
Hey, Daniel, can I just ask a question there? Because I want to make sure I'm interpreting this correctly.
Sure.
So like you said, this was your first commit to Airflow, this Herculean beast of a project. So
yes.
Trial by fire right off the start.
Yes.
And I guess what you're saying is like, hey, you put something out there that accomplished some use case, right? And then as people started using the executor more and more, you needed to hit different parts of the Kube API. And that was not really an issue, but because Kubernetes is moving so fast as is, you were kind of you have to like, you're almost running a three-legged race to some extent, right? Because you're trying to make things simple onto something that's changing.
Yeah, and and a big part of why I'm talking about that is to kind of, for anyone else who's building an open source API, I think it was a good lesson to learn. And it was a really interesting, contributing a thing to open source is maybe 20% of actual open source contribution. Once you've contributed a significant feature to an open source project, it is alive. And being able to take feedback from the community, see how people are using it, and think, okay, what is that next non-experimental iteration? What is it? What are the things we can learn from these people who are running this in production? And how can we take those lessons, build something that is better, that is more resilient, that better meets the needs of a wider array of people? I think that that is how you end up with a really hardened, really well-built open source project, is iteration and learning. And yeah, so it was honestly a great experience being able to talk to people who have, or when you contribute something to open source, one thing that's really great is you will always be surprised at how people use it. And I was very surprised by some of these use cases. I learned from them, and we were able to use those lessons to build something that we think is a lot better, a lot faster, and a lot cleaner.
Awesome. Thanks for that explanation.
Absolutely. Why is it not? There we go. So now we have this new architecture, which is every single step along the way, you are using the Kubernetes API, specifically the v1 pod API. And what's really great about that is that now all we need inside of Airflow is the ability to know the logic of how do you merge two pods together. So you start out with the pod template file, which we'll talk about later. You use your executor config on your individual tasks, you merge them. Now you end up with this base worker pod. Well, now you need to do the pod mutation hook before you launch it. Well, we use that same logic to merge again. So every step along the way, you are using exactly what exists in Kubernetes, which also means that the system runs much faster. And we were able to remove 4,000 lines of code compared between Airflow 1.10 to 2.0, which means there's that much less surface area to maintain, and the product is that much more stable. So let's talk a little bit about what the pod template file is. The pod template file is essentially a YAML file that you define a pod the same way that if you were launching a Hello World pod into Kubernetes. You have full access to the Kubernetes API, so you can say, I need, for this pod template file, I need these environment variables, these volume mounts, this node affinity, this image restart policy, this health check. Anything you want, you can put into this, and you can define the default in your airflow.cfg by just offering a path of like, this is the path to my default pod template file. But as you'll see later, you can actually maintain multiple of these files and pull them in as needed. So you might have different environments. So you might have your prod environment, your secret environment, your GPU environment, and your data engineers don't need to know all that stuff. They can just pull in the pod template file for that task.
Hey, Daniel, before you jump over, just a question from the chat and then a question from me again.
Yes,
first off, is this functionality where you have direct access to the v1 pod API, which version of Airflow is that supported in?
So we start to support it in Airflow, I believe 1.10.12. And we do so in a way to essentially allow backwards compatibility, because we want you to use the pod template file before you switch to 2.0. So it's an important step to upgrading to 2.0. But so it starts in 1.10.12, although I do believe that 1.10.15 is now the official bridge release of Airflow. So it starts there, but as of 2.0 onwards, it becomes the default, and any new features we add in will only be 2.0 onward.
Gotcha. So you should probably use this 2.0 forward, just given that it's going to build up from there.
Yes.
And then question from me, just to make sure I'm tracking with this, because I'm a little new to the certain parts of this level of deep into Kubernetes land. It sounds like what this pod template really lets you do is pass in your defaults up until the point you need them. And then when you need to change something, this gives you an easy interface to override something, be it a volume mount, a subdirectory, or even the image itself. Is that kind of the right way to think about it?
So when you say deep, like, if I understand what you're saying is that the pod template file allows you to create the defaults, and then when you're launching your task, you can then use the executor config to override those defaults as needed.
Exactly.
Exactly.
Mhm.
So as you'll see as you'll see later on, you're actually able to import a custom pod template file and then add your overrides on top of that. So with the executor config, we now have what's called the pod override object. For those of you who have used the Kubernetes executor for a while, I'm sure you know that there's kind of this executor config object that essentially is just a dictionary, and that dictionary is all custom stuff to Airflow. So you can change some things and some things you can't change. And now we just expose it and say, no, this is all, you can do whatever you want, create a Kubernetes v1 pod object. You have the type checking, you have the code completion if you're doing this in a IDE, and you can use the Kubernetes Python library to build this object, put it into the pod override section of the executor config, and then those overrides will show up in your pod that is running. And you can actually now use the official Kubernetes API reference. So you have access to all of that documentation. And this makes it arbitrarily easy to say, add in a sidecar container, or add in a secret or a node affinity. And Viraj, I believe you had mentioned at one point that a common use case is Kerberos, where, let's say you have a pod that you have a task that needs access to Kerberos, and so you need to pass that token. You can create, you need to pass a token, but you don't want your Airflow pod directly speaking with Kerberos. You can now add in a sidecar container and then add in a shared volume mount between the two. And now with just a few extra lines, you now have you now can launch an Airflow task with native integration into Kerberos.
So this really harps on, I think, what you were mentioning earlier, where the kind of one of the design thinking of the Kubernetes executor was to give your data platform engineer, data engineer, better room to collaborate. The data platform engineer says, hey, you need to do things this way. The engineer says, give me an abstraction layer to do that. And it seems like this is an easy way to start having those conversations within teams.
That's absolutely the case, which also ties into the ability to have these custom pod template files. So let's say I'm the data platform engineer and I want to tell my data engineers, hey, actually use Kerberos when you're doing these tasks. I can create a Kerberos template. And so if they're using the Kerberos pod template file, the data engineer doesn't even need to know how Kerberos is mounted. They just know, okay, I use this pod template, I add these labels and these environment variables that I personally care about, and then magically my task will work with Kerberos.
That's awesome.
And one thing that's really nice on the UI side of things, and this is only 2.0 plus, is now we have this KEDA pod spec rendering in the Airflow UI. So as you change your pod template file, as you change your executor config, you can then go into the Airflow UI, click on this tab, and you will see exactly the pod we are about to launch before you launch it. So you can go in and say, hey, that volume doesn't look like the correct volume. Hey, I actually expected this environment variable to be there. Let me go back into my code and look up what is not being done correctly. And that way you don't have to launch a pod and then see go kubectl in and then see what's going on there. It's all in Airflow for you.
So in this example here, I could see hey, this task is supposed to launch on a specific node affinity to make sure it's getting launched, maybe on a GPU node or whatever my use case entails. Very cool. And I don't need kubectl anymore, so I don't have to go learn a new CLI or have to ask my ops team to give me direct access to the Airflow cluster. This kind of empowers me to self-service data engineering.
Exactly. And node affinities are such a powerful thing. You might have one task in your entire pipeline that needs to touch the personal information section of your cluster. And so now you can easily, so a good example would actually be GDPR. You might need to do certain tasks that can only exist on servers that exist in Europe because of GDPR. And so now you can have this multi-region DAG where each task knows what region to exist in.
That's awesome. And the data engineer doesn't have to do anything to take advantage of that Kubernetes is providing that abstraction layer that they can just say, hey, run this, and then the task will just know where to run.
Exactly. So those are the main new things in the Kubernetes executor. And now let's talk a little bit about the Kubernetes pod operator. So probably one of the cooler new things about the Kubernetes pod operator is that it's now actually a separate provider, and it's no longer a part of core Airflow. And that's really beneficial in multiple ways. Probably the biggest one is that the Kubernetes pod operator is no longer bound to an Airflow version. So if you're on Airflow 2.0.1 and you have some fix that you need for the Kubernetes pod operator or new feature you want to use, you only need to upgrade the provider and not Airflow. And as long as there's no breaking core changes, for the most part, we try to make it that providers can upgrade as long as possible without requiring an Airflow upgrade. This also means that for those who are upgrading to 2.0, there are now backport providers. And what these backport providers do is they offer a 2.0 Airflow 2.0 compliant API for the Kubernetes pod operator, so you can upgrade at your own speed. And then once you're using these providers, your DAGs will work in Airflow 2.0.
Much faster iteration cycles then, right? Because I don't have to try to upgrade my entire instance of Airflow just for a new feature on the Pod operator.
Exactly. So you can, like, the providers will be released at a much faster cadence than Airflow core, and they will require much less upgrading on your side. It's just upgrading the version of a pip package. The new Kubernetes pod operator now takes in Kubernetes objects, which means that instead of the airflow.kubernetes.volume object, you can actually use the KEDA v1 volume object. So you now have access to all features of a Kubernetes volume, all features of a volume mount. You can use their API, you can use their documentation, make sure that everything is one-to-one compliant, and then add them in as you would with a normal Kubernetes pod operator as arguments. But you can also now have pod template files and KEDA v1 pod objects, add those in, and then Airflow will do the overrides. And then you can, even on top of that, add in your custom individual arguments, which will be added at the end. So it creates this really nice flow where you can have one pod template file service 10 to 15, like 10, hundreds, however many tasks you want. And you start with the same template and you just change the environment variables as you need them. So for example, if you were doing hyperparameter tuning, you can use the same pod template and just change the environment variable. And based on that environment variable, you will change the hyperparameter.
That's pretty awesome. And that makes the, even like, what I'm really seeing here is it really opens the, or adds to the breadth of use cases Airflow can be used for, strictly on a user experience part, right? Where, like you said, if I'm doing hyperparameter tuning, I can make small changes and get big outcomes from those small changes, all in a very controlled fashion, because once again, my data platform engineer is writing these abstractions for me.
That's exactly the idea, is like, you don't have to write these giant objects in your DAG. They can be in these separate files. They can be kind of standardized. So, if you have a pod template, a single pod template file, how that pod template will work across each of those tasks, and what changes you can have by changing small things on top of it. So it minimizes the code in the DAG while still giving full access to the Kubernetes API. And now I want to talk a little bit about KEDA. So as we mentioned before, with the Kubernetes executor, every single task you launch, Airflow speaks to the Kubernetes API, launches a pod for that task, and then runs that pod to completion, which for a lot of small to mid-sized use cases works fantastically. It gives you the flexibility, it gives you the visibility into how your tasks are running and the auto scaling. But for really, really large scale cases, this can get very unwieldy. So if you're doing thousands of tasks at a time, you're now launching thousands of pods at once in your Kubernetes cluster, and that can start putting pressure on your cluster. So we looked into kind of what are the best parts of the Kubernetes executor and what are the best parts of the CeleryExecutor. And with the Kubernetes executor, you have dynamic allocation and the executor config. With the CeleryExecutor, you have these immediate SLAs because once a Celery worker is running, it is able to run, like take on new tasks immediately. It's already hot, it's already been started up. And you have this multi-tenancy, which makes it a lot more efficient. So we tried to figure out the best way to do both of those. And we figured out the system KEDA, which is part of CNCF. It's the Kubernetes event-driven autoscaler. It basically allows you to create custom autoscalers. And we at Astronomer actually created a Postgres autoscaler and donated it back to the KEDA project. And the way that the Postgres autoscaler works is we're able to query the Airflow metadata database and say, hey, based on how many tasks are running, plus how many tasks are queued, divided by the number of tasks for workers, how many Celery workers do we need for this queue? So if we add a single task, KEDA is like, all right, you need 1 Celery worker. If we add 40 tasks, it's able to say, all right, 40 tasks divided by 16, you probably need about 4 workers. And it launches those 4 workers, runs those tasks, and then scales back to 0 once it is all completed. And what's really nice about this is traditionally, the more Celery queues you add, the more complexity you add, because you have to handle scaling for all of those. But if all of your Celery queues scale to 0, you could have 20 different queues with 20 different configurations, and all of those queues will scale to nothing, so they don't cost you anything. And finally, I want to talk just a little bit about what's next with Airflow and Kubernetes. And probably the thing I'm most excited about is this task.kubernetes extension to the TaskFlow API. In Airflow 2.1, so the TaskFlow API came out, it's been very popular. And one thing that we've been noticing is people want more flexibility than just the Python operator. How can I run tasks that exist not just with the same environment as my Airflow? So in 2.1, which should be coming out in the next month and a half, we're starting out with the task.virtualenv, where you can actually define a custom Python virtual environment and import custom libraries. But probably around Airflow 2.2, we're going to have task.kubernetes, where you can give a pod spec, give like a Python function, and we will be able to inject that Python function into that pod spec. And as long as your image has a Python library, we can run this code in that Python library. So you could have a TensorFlow image, you can have a crypto image that like has certain cryptography libraries. And as long as we can do a Python command, we will be able to run your code in that image without any extra work.
So I think in terms of needing to know Kubernetes to get the benefits of Kubernetes, this almost takes that entirely away, where all I need to do is just find my task and give this little decorator, and I'll just inject it right on in.
Exactly.
Yeah, that's awesome.
All right. And so that is all I have so far, and I'm very excited to see if there's any Q&A.
A few questions in the chat. I can shoot them to you.
Sure.
Take them from there.
Yeah.
So this one, I can't pronounce the name because I think it's in a different language, but if I use a local executor with an autoscaler for the Airflow pod, what are the benefits of the Kubernetes executor over the local executor?
Use a local executor with an autoscaler?
Yep.
So, I mean, one big thing is that we tend to not recommend using the local executor in production. So with the local executor, if your scheduler goes, because with the local executor, the pods are running in the scheduler. If the scheduler goes down, you basically lose any running tasks. There's no way to continue them. One really big thing that really great, this is probably one of the most important features of Airflow 2.0, is we now have scheduler HA. So you can actually, with the Kubernetes executor, run multiple schedulers. And if one of them goes down, the other schedulers will adopt those running tasks so that you have 0 outage time. With the local executor, if your scheduler goes down, the tasks themselves existed on that machine. So they've basically disappeared.
And to really take advantage of that AGI, you want to be using that distributed setup, right? You don't want to have your tasks run inside of those pods natively, because then you lose some of that resiliency.
Absolutely.
Cool. So we have a question from Gabrielle Machado to talk about the Astronomer Airflow Helm chart and the one inside the official Apache/Airflow repository. What's the relationship between the two? Are there breaking changes between them? And what does that piece of the puzzle look like for someone wanting to run Airflow, wanting to run an Airflow Helm chart?
So I would say that the Astronomer Airflow Helm chart has been a little bit more battle tested. We've been using it on our customers. The open source Airflow Helm chart is actually pretty heavily based on the Astronomer Helm chart. And I think that over time, we plan to try to bring a convergence to allow people to use either without there being breaking changes.
Yeah, just kind of bring those into the umbrella of the easiest way to run Airflow on Helm. Question from Hernan Diaz. Can I choose some tasks to be launched with Kubernetes and others to be launched with Celery or local?
Yes, actually. So in Airflow 2.0, one thing we've released is called the CeleryExecutor. And the way that the CeleryExecutor works is you have these queues for Celery. And if you set the queue to Kubernetes, that task will actually be routed to the Kubernetes executor. So you can use the CeleryExecutor for things that you want to do efficiently. And then for the tasks that you want to do with customization, you set the queue to Kubernetes, you put in your executor config, and you have all the benefits of the Kubernetes executor.
So best of both worlds there.
Best of both worlds.
Very cool. I think this is a question that people ask a lot, so I think it's good that we're answering it here. But what's the primary difference between the Kubernetes executor and the Kubernetes pod operator?
Absolutely. So I would say, and we do get asked this a lot, and the Kubernetes pod operator is essentially a Docker operator. It is I have this image that I want to run. This image has no idea what Airflow is. It's not an Airflow related thing, but I want to run this command in this image and monitor it and make sure it ends up correct and possibly pull some output from it. The Kubernetes executor is much more like, I want to run the Python operator with these, on this GPU machine, or I want to run this Salesforce operator and inject this secret that gives me access to the Salesforce API and only inject this secret into this task. So the Kubernetes executor is when you want to do things that are a lot more native to Airflow, when you want to take advantage of Airflow's operators. And you can absolutely use the Kubernetes pod operator on top of the Kubernetes executor. But if you're only using the Kubernetes pod operator, it's actually probably a little bit more efficient to use the CeleryExecutor.
So I think one thing that we've seen a lot is if you have DAGs that are pretty similar in their tasks, right? Like every task is doing a very similar thing. You can probably use a CeleryExecutor pretty well for that, especially if you have autoscaling hooked up with it. For any sorts of tasks where one task is very different from one another, maybe your first task is running a query, and then the task after that is running a machine learning model. On those quote unquote diverse DAGs, I think the Kubernetes executor is a great failsafe because then you can configure each of your tasks to be super different from one another. Cool. So we have a couple of questions on how to use KEDA. I'm not sure if there's an easy way to get started with it right now, Daniel, that you could point users to.
So in both the Astronomer and the open source Airflow Helm chart, there are instructions on how to use KEDA. Essentially, KEDA itself has a Helm chart, so you can Helm install KEDA onto your system, and then you can actually there are actually I think it's like worker.keda.enabled. If you set that to true, then using either of the Helm charts, it will launch Airflow with the CeleryExecutor and with KEDA enabled, so your workers will auto scale.
Yeah, we'll send out a link to that Helm chart as well right after the webinar as part of the follow-up. We got a few more questions here, Daniel, so I'm just going to keep feeding them to you.
Yeah, absolutely.
This one's a tough one. I think that we've worked through this one on our cloud product at some point, but what are best practices around using Istio proxy with the Kubernetes pod operator due to security requirements? I know that's something that you've worked through before. Would love to have a session. Would love if this person wants to drop their email, we could follow up with you offline on it. But just wondering if there's anything off the top of your head that you would recommend there.
Yeah, I mean, that's a funny one. Yes, like we could definitely talk offline about it, but in general, where the Istio proxy gets interesting for the Kubernetes pod operator is that even the way that Airflow works is it expects the pod to stop. And with Istio, even if the main task stops, the Istio server will continue to run. So you probably would need to add an extra sidecar that waits for the main task to complete and then pings Istio to say, hey, shut down because the main task is done.
Istio just adds a layer of complexity on everything. So
yeah,
definitely a bunch of little things you'll run into as you get started with that. So question on some of these cool new decorators you're working on. Is there going to be an easy way to access connections and other libraries from within the decorators?
So you can access the Airflow-based stuff if you're using the Python, like just the base Python, like I'm in my worker, I'm in the same Python environment as the Airflow worker. For the Python virtualenv, maybe. For the tasks.kubernetes, no, because the tasks.kubernetes is going to work the same way that the Kubernetes pod operator works, which is completely independent from Airflow. If you are trying to access connections, if you're trying to access things that are in the database, you're probably better off using the Kubernetes executor and then doing a, like adding in whatever things you need to the executor config and then doing a task.python or a task.virtual.
Really interesting. So I think that's another best practice that we can maybe write a blog post about at some point. But it sounds like that if you want to use the default Airflow connections, Kubernetes executor is the way to go. But if you're using the Kubernetes pod operator, you should think of your own way to figure out how connections are going to work. Is that right?
Yeah, I think a good general rule is that the Kubernetes pod operator has no idea what Airflow is.
Yeah, that is a good general rule. Yeah, wow. Question on the same thing there. Can I stream logs generated within the Kubernetes pod operator into Airflow?
When you say stream logs, I'm not sure what you mean by that. Like, do you just mean like the logs like while the task is running? Or?
Yep, exactly.
So there's two main ways of doing this with the Kubernetes pod operator. Probably the most recommended way is to have some form of an elk stack or some form of a just general logging system on your cluster where you have like some sort of a daemon that's like taking it to like a centralized log hub. And if you have something like that, you can easily connect that to Airflow, and then your logs will stream in. I believe that as of Airflow 2.0.1, we have the ability that even if you're using something like S3, you can still see your Airflow logs running live from the Kubernetes pod operator. That I do believe that is a more recent thing. If that is still not a thing, then I ask you to submit a ticket because that should be something that works.
So generally, if you're using a Kubernetes pod operator, your advice is to have a cluster-wide logging solution, such as your Elk stack or something, then just have Airflow read from that.
Yeah, I mean, like I would say that I'm not saying, oh, you need to start from scratch and build like a whole Elk logging stack just to use Kubernetes pod operator. But I think it's just a good general best practice in Kubernetes in general that if you're using a cluster in production, you should have some sort of a like searchable log for everything. That's just a general best practice.
Yeah. And then one last question on logging. is there a plan to support logs or standard out available in worker pods that aren't just remote logging? So I believe the Elasticsearch task handler should help with that, right?
Yes, I believe we have an Elasticsearch task handler and an S3 task handler that will actually take the logs from the worker and stream them into Elasticsearch or S3. The downside of the S3 task handler is that I believe for that one, the logs won't show up until the task is completed. But it might, as long as you have some sort of a service that's able to speak to the worker, I believe Airflow will, if Airflow does not see the logs in S3, it will attempt to speak to the worker and get those logs from that worker.
Awesome. Any other questions from anyone in the webinar here? Looks like we finished a little earlier than expected. That's probably a good thing for a Monday. Give everyone a little time back.
I see one question about KEDA.
Okay.
What is the required scope for KEDA? I think that in general, KEDA really makes sense if you're doing like large scale. So for example, I remember one time trying to help someone get set up with KEDA, and then it turns out that like they actually only ever needed one worker, and you know the cost savings of a single worker don't quite match the extra complexity of KEDA. But if you're trying to scale to like 10 worker, because if you have like, let's say you have like a lot of surge, so most of your day you're doing nothing, and then a couple times a day you suddenly are running 100 or 1,000 tasks at once, and then it goes back down to 0. That's a really good use case for KEDA because the auto scaling will really show notable speed improvements and notable efficiency improvements, as opposed to if you only ever like run like 5 or 6 tasks at once, having like one extra pod running in your Kubernetes cluster is not going to add that much to your AWS bill at the end of the month.
A few more questions just jumped in here, so I'm gonna get them. This question is from Plinio. Any best practices around running Spark on Kubernetes using the KubernetesPodOperator? Is that a use case you've had to tackle before?
I haven't personally, but I guess the question I would have is, are we, because there's a lot of variables there. Are we talking about an external Spark cluster, or are you using the native Spark on KEDS? Where if you're using the native Spark on KEDS, you know, there's a Spark on Kubernetes operator where you can even just use the regular Spark operator and just make the URL a KEDS URL. So yeah, unfortunately, I don't know if there's like a specific best practice for that.
I think Faisal on our team actually did that at one of his old jobs. So we can definitely, Pino can talk to Faisal there. Cool. How about metrics? You know, what's the best way to push metrics from an Airflow worker to Prometheus? Is there a scrape interval I could use or a scrape point I could use there?
I don't personally know. Funny enough, that would be a great question for one of our infrastructure people.
Yeah.
Who do exactly that.
Yeah, exactly. I wonder if there's additional metrics that we could get out of there if we like give it a deeper look. So feel free to follow up with us on that question. Fortunately, I didn't see who asked it, but feel free to shoot us a message on that particular point. Cool. I think you answered a version of this question just now, but I'm going to ask it again just to be clear on it. What are some considerations you should think about when you're picking between the KubernetesExecutor and the CeleryExecutor? You know, what are some of the pros and cons around both of them and parameters you would consider as you're picking the executor that's best for you?
Yeah, so I would say with the KubernetesExecutor, I would ask, how varied of a use case are we talking about? Like, are we having some data science tasks? Are we having tasks that might require like different C++ or system libraries? Are we having tasks that some tasks will require access to a GPU cluster? Do you want to expose that to the data engineer? You know, if you're in a very locked down situation where you only want people to ever run exactly in the environment you're creating, you might not want them to have that flexibility. But if you're an infra engineer and you don't give that flexibility, you also have to consider you're going to probably get a lot more tickets.
Yeah, yeah. I think that everything I've seen from working with customers, that answer holds true. It's really when you get to really exotic use cases or airflow environments that have DAGs that are doing different things is where Kubernetes really looks interesting. Or if auto scaling is a must-have. But I think Celery is a great executor to use, especially for ETL type workloads, as a lot of those workloads will tend to be, those tasks will tend to be pretty similar in profile.
Yeah, so a perfect example of like where would CeleryExecutor really shine. Let's say you need to run a lot of ETL workloads, all of which are using like some sort of a cloud API or talking to the same Hadoop cluster, or you're okay with kind of sharing secrets across systems. You're mostly talking at APIs, so you don't really need to like worry about one task needing GPU access, and you just need something to like orchestrate these external systems. That's the place where CeleryExecutors, the efficiency of the CeleryExecutor can really shine.
Looks like the last question in the chat. How can we configure the Celery Kubernetes executor? Should we use Celery Kubernetes executor or KEDA with CeleryExecutor?
Porque no los dos. I actually think that the Celery Kubernetes executor with the KEDA autoscaler works fantastically, because now you have auto-scaling Celery workers for your high load stuff, and then you have the Kubernetes executor as an escape hatch for if you have like a couple of tasks that have those more exotic use cases.
Yeah, it's a great question, Adeline. Awesome. So we're at 48 past here. Oh, looks like one more question just came in here. Oh yeah, and then I think this goes in the same line there. How do you estimate the number of workers that you need?
Well, so that's an interesting question in that part of it comes down to your SLAs. So if you once a day get 1,000 tasks just hitting your Airflow, but you also only need those 1,000 tasks to be done over a 24-hour period, you could get away with having one worker. If you have those 1,000 tasks and those 1,000 tasks all need to be done at the same time, you're probably gonna have to surge up to 10 workers to get those tasks done and then surge back down. So the big question you should ask is, how many tasks are you trying to, what is your like maximum parallelism you need to meet your SLAs? How can you scale down when you don't, once you're done with those SLAs? And are you talking about a consistent workload or a surge workload? Those are probably the three questions I would ask when trying to figure out how large of a cluster to build.
Yeah, I think that's a really good framework for it. Good follow-on to this next question here. If you're using a tool like EKS or GKE or any of the managed Kubernetes offerings, how do you configure the Celery executor? Is it as simple as changing the CFG, or are there additional steps that you have to take?
Well, I mean, if you're using the Helm chart and you change the executor to the Celery executor, all of that is actually programmed in very automatically. And so if you change it to Celery executor, it'll automatically launch with a worker. If you turn on KEDA, it'll automatically start to auto scale. So Helm handles a lot of that complexity for you.
Yeah, especially with the abstractions that we expose in our Helm chart, you can just change that one sort of thing there, and you'll be good to roll. The one thing you'll have to do is also just make sure you connect to a Redis intermediary for Celery, because you need that message broker for it. Awesome. Alrighty, everyone. Does not look like. Oh, one more question from Adeline again on KEDA. When we use KEDA on managed Kubernetes services, what are the required scopes?
So the only issue we've run into with running KEDA on a cloud managed service has been on EKS. We had one user who was running on EKS, and then they ripped out the DNS to put in Calico. And from what I recall, the problem there was specifically how EKS communicates with Calico basically meant that the KEDA was unable to communicate with the Postgres just for some network policy reason. So I would say if you're using a baseline cloud managed Kubernetes, KEDA should work out of the box. If you are using Calico, I believe there are features that Calico needs to implement before that will work.
Last question was, when will we share this out? So in the email follow-up, if you put your email down, you'll see a link to this, to the link as well as show notes for it. And it should be on our blog in the next couple of days as well. I think that's a wrap, everyone. Daniel, thanks so much for hopping on and answering questions. I think you answered about 15 of them without missing a beat between them. Sorry, 19. So that's all in a day's work.
My pleasure. Thank you all so much for coming out, and I look forward to hearing about all of your Airflow use cases.
Awesome.